So when I arrived in the car park last night, I was a little bit worried because my phone was still on a 4G network and it hadn't suddenly roamed to this, random other network or something. I thought, oh my goodness, James isn't here. What's happening? But thankfully, sat down for a beer last night and James arrived. But we don't have a secondary mobile network here yet, do we? We're about to have one.
Not
Brilliant.
Yet, but we will have. It's in the bag.
So live off the set of The Only Way is Chalk Valley, we've got James Bodie here who's going to tell us about building a 4G network. Or we're going to actually build one, aren't we? Is that the plan?
Yeah, might not be right now, because there's a background to this. Because, okay, can we put this up? Perhaps, maybe. Has my Mac gone to sleep? Because it's running on battery. It has gone to sleep. Because good. Because I'm running on battery. There's nothing like living on the edge, is there? So 48 hours ago, I was tucked up in bed with an elephant leg and a 39 degrees centigrade temperature, which I think is quite high, and feeling really grotty. I've been bitten by a tick on the leg, and it swelled up like a balloon. And I thought for an awful, awful, awful moment I would not make it here. But thanks to the NHS, here I am. So you have to suffer me. But there's a small downside, which, as usual, the slide pack is not as complete as I might like, and the demo is definitely not tried and tested. So I'm not going to be doing the really dangerous bits. But we'll do that later, don't worry. So today I'm going to talk about building 4G networks out of open source components. Not an easy task, because if it was easy, we'd all be doing it. But yeah, let's talk about that. Yeah, my background. I've spent the last, 15 years of my life building mobile networky bits. I built most of the core for TruePhone, if you come across them. Interestingly enough, last week, some idiot valued TruePhone at 1.24 billion. I don't know how they managed to do that. But anyway, they seem to be going okay now that I've left. I left about 2.5 years ago, taking the R&D and innovation teams with me, with an objective of setting up and using private LTE networks as easy as deploying Wi-Fi access points. Now, that's a bit of a bold thing to do, isn't it? So, a bit of background here. There's a traditional way of building mobile networks, and this is the way you do it if you're a mobile network operator. You do all this stuff, and it costs you huge, huge amounts of money. Well, I'd say at least £6 million. I'd say probably more than that if you're a Vodafone. A lot of money. And this is what it looks like. You start off with a room like that. You put a UPS in there that's about the size of a Ford Transit van. You put in racks, loads of fiber optic cables, and it looks a bit like that. And it takes a long time. So that's the way you do it traditionally. There's a slightly more modern way of doing it, which is to do it this way. You use general purpose platforms, and you buy, this is the wrong, no, this is the right version. There were mistakes. You buy software from smaller, more specialized people, and you can build the whole thing from flash to bang in about 6 months. And I think this is what Sipgate are going to talk about later on, a slightly smarter way of doing it. And you can probably do it with 1 or 2 people plus suppliers if you're really, really smart, with a cost of around that. But that sort of money is still out of reach of most of the guys here who just want to try a bit. You want to dabble, you want to open source it, don't you? Because we're that kind of guy. So it's to those type of people that I'm talking now. Oh, by the way, that's the cheaper version. And why is somebody? Oh God, I've picked exactly the wrong time to ring. I bet he's watching this actually. Because I just named someone on there, and all of a sudden I get a phone call. Funny that, isn't it? Yeah, this is the traditional simplified wiring diagram of what an IMS network. So the 4G core, according to 3GPP, looks a bit like that. I mean, that's just makes your eyes bleed, doesn't it? So can we simplify that a little bit? Well, I think we can. If we just look at the whole thing from a protocol perspective, what is IMS? Well, IMS consists of SIP, which most of us know quite well, plus diameter. What's diameter? Simple joke. It's, Evan's saying, don't say that line again. Yeah, it's a bit like radius, but just, yeah, but twice as good. Yeah, I know, it's corny. Well, actually, a load of you will know what SS7 is. Well, it's like SS7, but about 10 times better, because you can do a lot more with it if you can get your fingers into it. But the problem with diameter is it's a little bit more difficult to get into. How do you interconnect, get a diameter interconnect? It's a little bit tricky, but more of that later. And then, just for an extra twist of complication, instead of using either good old UDP or TCP, which we all know all about, 3GPP chose SCTP. Yeah, good old SCTP. Anybody here used SCTP before? Oh, I'm impressed. Good. Well, you would, wouldn't you? There's no choice, really, is there? But SCTP has some really good things going for it, which is why it's chosen. It's really is good stuff. But just mentioning it just adds an extra complexity. So how do we take that 3GPP diagram and make it simpler? Well, this is how you kind of do it. You'll note that just about all the boxes become Kamailio. All of a sudden, that's looking a lot better, isn't it? That looks like a really good IMS core. Thank you, Daniel, Miela, and team. I cannot thank you enough, particularly the contributors who did all the IMS bits and pieces. Absolutely brilliant. This has got SEMS in there because it came from somebody who had a bit of a Germanic background. You don't have to use SEMS. You can use FreeSwitch, or even, if you really want to, Asterisk. Not a problem. Tap. Okay, things that will definitely stop you. The biggest hurdle for most people is this one, spectrum. Fundamental problem is that all of the usable mobile spectrum, that is the things that your mobile phone can actually work on, have been licensed by the governments to the big mobile network operators. And that's a bit of a problem, because if you kind of get access to spectrum, then you're kind of stuffed. You can't go anywhere. But the good news is that times are changing. In the US now, for about 2 years now, there's been a band called CBRS, Citizens Broadband Radio Service, up at 3.4 gigs, which is now open for anybody who wants to use it to get a dynamic license. So you can just apply for a spectrum lease in a similar sort of way to DHCP, but for spectrum, not IP addresses. And in the UK, it was announced, good old UK, after a lot of lobbying by certain people, we've actually managed to extract for the government not one, but 3 shared access bands, and the ability to, when you go to a place where none of the spectrum's being used, you can actually apply for a license for any of the mobile spectrum. Whoa. And across Europe, we're seeing, across the world, we're seeing this concept of shared access spectrum becoming more and more popular. Why? Because it's the only way we're going to cover the not spots. Yeah. Oh, and then, of course, you can use LTE, 4G, on license-free spectrum, like the 5 gigahertz band. Right. Yeah. Okay, this is the way it works in the US. They have a thing called the Spectrum Access System. When you turn on your 4G cell, by the way, I've got one here, and you'll see this on a slide later. This is an experimental one belonging to the gentleman that just called me on my watch a second ago. When you turn the thing on, what it does is it reports its location and operating parameters and everything that it can hear around it. And based upon that report and what's in the database, the SAS then issues you a lease for Spectrum for a period of time. That's the way it works, isn't it? What's going on in the Spectrum space right now? These are the bands that are available to us. Later, we'll be putting this particular cell on, making it live, using that very top band, the top end of band 3 in UK. But all of these other bands are kind of available. Some of them are more available than others. Interestingly, in UK, we're just about to get this bottom one, 3.8 to 4.2 gigahertz, a massive band to run 5G waveforms in. That's an enormous band. That's the good news. The bad news is that none of the commercial devices out there today support that band yet. But in 5 years' time, that's going to be absolutely great. Whereas this top one, band 3, every single device on the planet supports that. Right. Whew, we've got Spectrum. We can pass go. Next thing we've got to worry about, identity and authentication. How do you authenticate yourself? This is the kind of old-fashioned way, SIM cards. If you want to build your own LTE network, where do you go to buy your SIM cards? This is a bit of a problem, isn't it? Because people like G&D and... Where do you get your SIM cards from? A big supplier. Yeah. So it's people that they go to. They won't do you SIM cards in less than, 10,000 batches. Well, luckily, there's somebody here who will supply you with 1 or 2 or 5. And so that's another thing we'll do for you. And these little babies are not your normal SIM card either. These things have got more processing power than a first-generation Pentium PC and about 10 times more memory and run applications independently of the phone. They also have multiple IMSIs. The IMSI is the Internet, just checking I've got it on there, the International Mobile Subscriber Identity. Normally, one SIM card will have one identity. These have lots of them. And to make things even better, we can OTA new ones in there. We can over-the-air rekey them. That's really cool. And what else can we do? Oh, yeah, we've got multiple sets of keys. A normal SIM card will only have one set of crypto. Why? Because it only ever has to authenticate in one place, back to the home network. But of course, if you're running your own, you probably want to authenticate on your own network, but then when you walk off down the road, you want to hop onto somebody else's network, don't you? Yeah, so which means you need multiple sets of crypto, as well as multiple IMSIs. And it does a whole load of other stuff. Oh, yeah, handset provisioning. Have you ever wondered how your handset knows how to turn on the Wi-Fi calling and VoLTE? The answer is this thing provisions it. Yeah, we do that as well. And if you didn't know, these things don't have one SIM in, they have multiple SIMs. They have a SIM, they have a USIM, and an iSIM. Each one does different things. Whew, enough to make your brain ache, isn't it? But anyway, we'll help you out with those if you need that. Those. Yeah, I think I've said most of that. This is a TruePhone thing that we did. We also did SoftSIM, which is currently embedded in the latest generation of iPhones. We did that too. You've probably seen this rather lame slide. So multi-IMSI is a bit like James Bond's Aston Martin DB4 with a rotating number plate. And as you drive around the place, you go across the border, you flip the number plate, and you're always local. Well, that's That's the line anyway. Yeah, we've done all of that. I think I just burbled about that. Oh yeah, you can also run your own private sim applets on there to do interesting stuff. But I don't want to talk about that right now. Now to pilot all of this, we had to set up a real live pilot. Now I live in a place called the Chalk Valley. It's in an area of outstanding natural beauty, southwest of Salisbury, not a million miles away from here. Absolutely beautiful, chalk streams with trout, herons, egrets, kingfishers. The Chalk Valley History Fair Festival, which Evan really loves, amazingly. I should have put a picture of you being assaulted by a policeman, actually. That would have been good for a laugh. But the problem with it is it's got no mobile coverage because when people came along to put up masts, the locals said, "You're not putting one of those up in my valley." And so they got no mobile coverage. And so we've got the biggest contiguous not spot in the south of England, in the Chalk Valley. And I live right there in the middle of it. And so I decided to do something about it. And so we formed a community interest company called Chalk Mobile. Note it's got 4 instead of an A because the 4 is for 4G. We thought that would be a good idea. And the phase 1 pilot deployed 5 cells to cover, strangely enough, my village, the village of Bower Chalk. That's where we put them. And this is kind of what they look like. Let me explain what we've got. There are some BT fibres lurking around through Bower Chalk. So we're able to pick up some BT fibre to back all this stuff. So basically we've got a gig fibre goes into the back end of a central node. This is a central node here. There's a little indoor bit inside. This is mounted on a cow shed at the top of the village. Starting at the top, this is a point-to-multi-point distribution kit, which then wings bandwidth out to some of the subcells, and I'll show you. This is a subcell here. So we're running a 500 megabit per second waveform from this down to that to power that thing. And then this is an Acceleran E1000 band 40 radio operating a 20 megahertz waveform, 2350 to 2370 megahertz on a specialist license. Little GPS antenna there for timing, and that is a beam antenna, sector antenna going out there. This is a subcell. This is actually on the village hall. That is one of these tiny little things, which actually does exactly the same thing, if not more, as that bigger box, but in a smaller package. But it's just got a bigger antenna, which, interesting enough, the little tiny one works better than the big one. But, you know, you live and learn. And it kind of works over a fair range. So the range of this thing is about 500 meters into somebody's house, bearing in mind that in Bower Chalk we have pretty thick walls. My house is about 450 years old. That's my chimney, by the way. For a guy walking down the street, it's about 1.1, 1.2 kilometers. Or if you're working to somebody who's got an external antenna remote house, it's probably about 3 kilometers range with this. And that's what it looks like in action. This is a slightly different configuration. Each cell we put up has got a different configuration. There's actually my house. I've got a gig fiber coming in. Again, point to multi-point, MikroTik, OmniTik. That's the timing mushroom, and then that's the OmniTik, this time with monopoles coming out the bottom. That's what it looks like. Very, very hugely simplified diagram here. Do I want to go through that? Yeah, so you've got the front end with eNodeBs, backhauling to a central point at the BT exchange. Interestingly enough, we found it's considerably cheaper not to put the kit in the exchange, but to put the kit outside the exchange in a cabinet and drill a hole through the wall. And then you don't have to worry about getting access to the exchange as well. Much cheaper. And everything we're doing here is about reducing cost, because cost is the one thing that will cripple you every time. What have we got there? Oh yeah, and then we backhaul back over a dedicated secure VPN back into Telehouse North, where we run our core. All the signaling goes through a diameter routing agent, again based on Kamailio. We've got an HSS there, which is the heart of the brains of the whole thing, which is not Kamailio, that's a commercial one, done for very specific reasons, mainly for interoperability. We've got an IMS core, again based on Kamailio, interworking function going off to SS7 via another operator, and then interconnects going into national networks. That's kind of the way it works. So the intent here is to run as a multi-operator neutral host. What that means is that if somebody turns up in the Chalk Valley with something like a Vodafone or an O2 handset, they've dropped off the end of their network, their handset will go into acquisition mode, they'll see the only network that's there, which is my network, they will try and attach to it, and as long as we can authenticate, they will get service. That's the way it works. The great thing about this solution is it scales right down to really tiny little islands if you want. You can have a single cell. So imagine that you're in Australia, living in an Australian not spot. You could have your own little private island of Whitey Mobile or something like that, couldn't you? And have people roaming onto you, which is why we've coined a new term for this, the reverse MVNO. Because with MVNOs, you have so MVNO SIMs roaming on MNO's networks, but with a reverse MVNO, you have MNO SIMs roaming onto your network. Nice one. And of course, it serves everybody. The great thing about serving everybody is that all of a sudden, you open up the possibility of lots of government grants. The government love this sort of thing. And in fact, the mobile network operators quite love it too, because they don't have a solution to cover these areas. It's not commercially viable for them to do it. So. How do we do the settlement? Well, one of the things we've done to reduce the cost is we've engineered out the rating and billing engine. It'll go back in at some time in the future, but we don't do rating and billing. We only track the totals of traffic. This is something we learnt from when Truephone bought a small rural operator in Montana in USA in order to get into the US market. We found that the US micro operators don't do this full GSMA TADIG-TAP record reconciliation because it's just brain damage. It's far too complicated and expensive, so don't do it. Instead, they just keep track of the totals. They call it mutual forgiveness. And they assume that there's a two-way flow of traffic. And as long as the traffic balance is roughly in balance, then you don't invoice. The great thing about no invoices, no tax. Hooray! And no complexity, no cost. It's brilliant. We love it. But you have to put in a mechanism just in case that seesaw goes out of kilter. And the way you do it is you, both sides put a lump of cash into escrow. So that if that seesaw tips and hits one end, it immediately triggers a cash payment, a recentering payment, which recenters the buffer. And you're back level again, off you go again. But that is about 100 times easier than trying to deal with these flipping TADIG tap record crap things, which are just horrible. Yeah, that's probably a bit technical, that, isn't it? But anyway, that's the way it works. Let's talk about the Evolved Packet Core, the EPC. This is the bit that sits in between the radio, this one is software-defined radio. I haven't really talked about that. I need to talk about that sometime. The radio and the IMS core. So the EPC is the bit which does all the local switching bit and allows you to drop data and traffic locally if you want to. There are lots of different ways of doing that. If you're doing it in your back bedroom, you might want to do it this way. This is a micro EPC based on a Raspberry Pi. I've got one here. In fact, I haven't got one here because it's not in my bag, so I can't show that to you. But this is what it looks like anyway. And that's great, but there's a better thing to use. These things. Anybody ever come across MikroTik? Yeah. Aren't they brilliant? I have this chap, the wonderful Prince Fred Mutiza, for sharing these things with me. Apparently, these are all over Africa. And there are people who put these into an office, and they whack FreeSwitch on this and run an Office PBX off it, as well as just doing the routing. Absolutely incredible. And they're awesome bits of hardware. And they scale right from one. I've got a little tiny one. It's about the size of a box of matches. It's so small. I've got 2 of them. I keep on losing them. How do you lose your router? I've lost my routers again. Yeah. And they're magnetic. They stick to things as well. But anyway, these are probably the best middle of the range ones to use. This has got quite a lot of memory. Is it 4/8 cores? I can't remember. Little touch-sensitive LCD screen so you can control it. It's got 5 gig Ethernet ports and 4 10100 ports. And it's just power over Ethernet. It's absolutely brilliant. And they cost about 100 quid. So, and about 20 times better than a Raspberry Pi. There's the OpenWRT people have built an image builder SDK and tool chains for this, both for the MIP and PowerPC variants of. So this one's a MIP, that's a PowerPC. They do come smaller and cheaper. So these are about 45 quid. If you really want to take on a Raspberry Pi. And these come in cases as well. And they give you the power supply too. It's just so wonderfully efficient. So you can run your EPC on one of these. Another great thing about these, the middle range and upwards all come with hardware acceleration for the encrypted link back to the core, which is the poor old Raspberry Pi doesn't have any hardware acceleration, and so suffers from that. Oh, and the fact that you've got multiple gig Ethernet means that dropping onto the gig backhaul is great. And this has got an SFP cage as well, so you bung your an SFP fiber module directly in there. It goes straight on the gig fiber. Hugely cost effective. I cannot praise these things enough. MikroTik, buy lots of them. They're brilliant. Right, what else have we got on here? Yes, some other obstacles, some other things that will stop you. The industry has set themselves up so that there are a whole load of key components that you can only access if you're a full member of the GSMA. And what do you need, apart from money, to be a full member of the GSMA? Answer, a full spectrum license, which effectively restricts the club of those people who can do things down to just the people who are wealthy enough to have these big spectrum licenses. This is an example of one of the key procedures. This is the famous IR21 procedure. So if you want your numbers to be routable and all your bits and pieces to work, you've got to have your particulars advertised on an IR21, and that needs to be disseminated out to the rest of the world. The great thing is that the GSMA have got an automated or semi-automated system to do that. So if you can fill in the form and get it into the system, it just promulgates and everything works. The drawback is if you're not a member, your name's not on the list and you're not coming in. Bit tricky, that. So how do you get around it? The answer is you find somebody friendly who is a full member and you slip all your stuff onto their IR21 and let them do it for you. In the old days, we used to do it with people like Manx Telecom, bunch of pirates, love them to bits. Jersey Telecom, there's the Icelandics. Who else do we used to use, Alex? I'm looking at you. Yeah, all usual. The Ireland Islands. Yeah. No, we never used that one. But anyway, so that used to be the way, and it's still the way to do it. But the good news is it's becoming a lot easier to get in because Spectrum is opening up. 4G is particularly more difficult because to do things like VoLTE, your phone will automatically try and look up the IP addresses for the IPNs using GSMA-owned URLs. So ims.mncmcc.3gpnetwork.org is owned by the GSMA. And the only way you can populate that is by being a member. And if you put your SIM card with your mobile network code, I didn't mention you need one of those as well. And they can be quite tricky to get as well, can't they, Alex?
Yes, they can.
And is Simon here?
No, he's not.
It's probably a good thing. I think he's still in threatening Ofcom with legal action because they refuse to give him one. But very politically sensitive at this moment in time. So you've got to have one of these mobile network codes as well. Right. I think are you standing up to say stop? Yeah. Well, very quick word about 5G. What's the difference between 4G and 5G? Both of them use a complete IP core, but 5G is being billed as this marvelous kind of answer to everything. Well, the answer, from my perspective, is it allows us to trade off in these three orthogonal axes. People know that 5G gives you this super massive, super fast bandwidth piece, but they don't know about the other two. One and the other two are latency, which is really important if you're doing something like driving a car, flying a drone, playing a musical instrument, Randy, or doing telesurgery on somebody. If you've got a long latency loop, that can completely bugger up your operation. It can be really bad. But you can't have latency with massive bandwidth. The two work against each other. Similarly, power and range work against the other two. So, for example, you might want to build a sensor that goes in your oil tank with a battery with a life of 10 years. But you can't have a battery that lasts for 10 years and do gigabits per second, obviously, because similarly, if you want a massive range, then you can have that, but you're not going to have the other bits and pieces as well. So what 5G really gives us is the ability to trade off between these three orthogonal axes, and a whole load of other stuff. Application slicing is another one. I've missed out huge amounts of stuff, and I haven't really talked about that yet. This is a software-defined radio. I'm out of time, aren't I? But we'll play with this later on in the week. This is capable of being 2G one moment, 4G the next. Nobody's bothering with 3G anymore. 3G is being phased out. 2G will live on for a bit longer because it's narrow, but 3G is going to go because it's not narrow, it's fat and flabby and not particularly good. 4G is great because every phone uses 4G today, just about. But anyway, we'll talk about that later. Have I got time for questions?
Maybe one quick one. We're about sort of 5 minutes over, so that's
Am I?
kind of okay.
Oh, no! Oh, I'm sorry.
One really quick question. Most burning question in the room.
Sam?
The multi-operator neutral host stuff.
Yeah.
With people roaming. How secure, how private is that? So if I'm a Vodafone customer and I'm roaming onto your Chalk mobile network, what can you see of the audio isn't end-to-end encrypted, is it?
Yes, it is.
It is
yeah, the
OPC?
only thing that I can see in the clear is that first initial attach. Mind you, I can mine quite a bit of information out of that.
Okay, not what can you do, but what's the normal? But yeah, so it is mostly
Well,
a secure.
what can I
it's
do?
not
Well,
like
I
when you're
can do
roaming
lots
on.
of stuff, actually.
It's not like when you're roaming on a classic 2G network where
Yeah,
your,
well, it depends
your switched
it
audio
depends
is.
which mode you attach them in, because remember there are always all the emergency modes, which you can do. You can even do it insecure if you want.
But it can be secure. For
Well, normally
roamers.
it will
So if I accidentally stray through your village and my phone roams onto your network, you can't listen to my calls.
Absolutely. The session keys are agreed between the home network and the SIM, and double handshake and secure. So, yeah, Vodafone would not be playing with me if it wasn't secure. No comment.
Brilliant. Thank you, James. I suggest folks who've got questions go and buy James something pink in the bar tonight, and I'm sure he will answer them.
What the drink is.